Hey everyone, I'm Kenny, and this channel is all about building AI that generates real world value. So, we are going to build a Langgraph agent that can proactively improve customer retention and increase conversion by automating email campaigns. Now, imagine your CRM actually working for you. So, no more manual emails, no more waiting for customers to drop off or disappear without understanding why. You only need to browse through a couple of posts on Upwork to see that there's a huge need for these types of systems. I went to Upwork and literally just searched AI agents and saw tons of posts asking for this type of agent. Here's one for marketing agency automations. They want to have bots that can do SMS follow up, send out emails, qualify leads, etc. This one is for outbound calls and emails. Here was another one for sending follow-up text messages. And then another chatbot looking for managing all of customer and lead conversations. So I've seen similar trends with job listings on LinkedIn, and now I'm going to show you how you can build one of these systems yourself. Let's take a look at the architecture diagram. This diagram shows the overview of the agent that we're going to be building. So we have our CRM agent and client, since we will be leveraging MCP for this. And while the data set that we're going to be working with is very specific in this example, it is for an e-commerce company selling physical products. But I want you to think about this design pattern and how it can generalize to all sorts of businesses. So whether you're selling digital products or subscriptions, it doesn't really matter. It's more about using the power of MCP servers like the Slack pre-built server and the Postgres pre-built server, and then incorporating even our own custom MCP servers like we will be doing in this example for generating marketing campaigns and sending out emails and doing really all of the marketing management for us, coupled with a database that would house all of our customer data, including not just customer demographics, but customer interactions with us. So their purchase history, their browsing history, etc. And so hopefully you can see how this example really generalizes to any type of business. This is really just a starting point, but it can be expanded in so many ways. But it is a very powerful design pattern, as we'll see in a bit. So pretty straightforward. Now let's check this out in practice. I've spun up our agent whose name is Ralph. He is our CRM agent, and we're going to start off by asking him if we have any active campaigns running. Like all of the agents that we've built in previous videos, we have the tool calls that are always going to be printed to the front end, and that is super important for being able to understand what the agent is doing. So the agent ran a SQL query to figure out if there are any marketing campaigns in the database, and this is coming from the Postgres MCP server. So Ralph didn't find any campaigns, and now rather than me having to figure out what campaigns I want to run, I'm just going to ask it if it can look at our CRM data. Since it has access to SQL and it can generate any SQL query, it can run some pretty complicated analysis against the database. So I'm just going to let it figure it out what types of campaigns we should run. Look through our CRM data and find any opportunities for campaigns. And so now it can go ahead and start doing some analysis. It comes back with 6 ideas, or rather it looks at these different segments of customers, and it's found some at-risk customers, some frequent buyers, some champions, and then it's suggesting a different type of campaign for each of these groups. So for the at-risk, we could run a re-engagement campaign. For the frequent buyers, we could be running a loyalty campaign, which we can ask exactly what that means. Same thing for the champion and For big spenders, we could be running a referral campaign or an exclusive offer campaign. So I can ask, what type of campaign is the loyalty campaign? And we'll kind of get a description back of what the loyalty campaign is. Of course, if you're in marketing, then you would know what type of campaign you could be running, what might be best, and kind of guide the agent. But with a simple system prompt, the agent is able to also just give you a lot of that upfront without you necessarily having to come up with all the details. So it kind of describes that we want to reward our high value customers for their continued support and frequent purchases and strengthen those relationships. So we could give them personalized thank you messages or exclusive offers and special discounts, etc. So we're kind of rewarding them for being loyal. Also, the agent has kind of broke down in its analysis how many customers we have in each segment. So this segment for at risk seems to be pretty big and probably somewhere where we could have a lot of leverage. So I'll just ask it to go ahead and run this re-engagement campaign. The agent will go and figure out what kind of data does it need to understand the customers in these groups so that it can create very personalized emails in this campaign. So it's done this analysis using SQL to look at the customers in this segment. And now it's trying to generate a campaign called re-engagement campaign for at-risk customers. Cool. And then it has a description. And then we're getting this human approval prompt. Human in the loop is a super important design principle when it comes to agents in production, since you want to be able to constrain them and approve their workflows or guide them if they are going in the wrong direction. So this agent has full human in the loop capabilities in that we can approve or reject tools, and we can also change the tool arguments ourselves if we wanted to, or give the agent feedback on maybe rethinking a certain tool call or giving it more context of what we actually want. So all of that is built into this agent. In this case, you can see we're prompted to either specify whether we want to continue with this tool call, update it, or provide feedback to the agent. I don't see anything wrong with this, so I'm just going to go ahead and say continue. So now the agent has created the marketing campaign and is now going to start drafting all of the emails. Okay, so that took about 30 seconds, but the reason why it took a little longer is because this agent knows that it needs to personalize these emails to this customer. So it's going to avoid sending generic emails as much as possible. And it's going to call now this send campaign email tool, and it's called it several times for each of the customers that it identified in this group. Now, each one of these emails is going to be personalized to that customer. And so if we look at some of this text, it's actually calling out some of the past purchases that this customer had with us. In order to do that, it had to actually query the purchase history for this customer in the database. But that's the beauty of giving this agent access to the Postgres MCP, where it can run these complex analyses and really understand the customers that it's working with. And then we get this human approval step. And again, I'm just going to hit continue. And then so it should go ahead and bulk send out all of these emails. Cool. So it looks like it sent out the emails. And if I flip over to Supabase, let this refresh. Okay, we can see the marketing campaign that it created. And if we just look at the description, it's the same one that we saw in the front end. And then if we go to the campaign emails, we can see that it sent out 5 emails. If we click into the body, we'll see the HTML for a given email. We can just copy that and throw it into this HTML render tool, and you can see what this email actually looks like. So again, it's very personalized to this customer, calling out previous purchases, including the purchase date. I know this date is super far back. That's because we were using a Kaggle data set, which I'll walk you through in a bit. So the dates are a little outdated, but nonetheless, you can see that this is much better than just a general email that would probably have really low conversion. And of course, we didn't do much to optimize this other than telling the agent to, hey, personalize the email. So you can optimize this much further by providing the agent even more context from the database if you had it for your customers, including browsing history, etc. Cool. So coming back to Cursor, I'm going to just end this session because I want to show you another feature. I'm going to completely close this session, and then I'm just going to change a setting that I have in our agent loop here, where in the agent state, I've defined this YOLO mode, which is just like in Cursor. If YOLO mode is set to true, then we won't be asked for tool approvals. And this is a really cool design pattern as well that you can set when you're building these types of agents that have human in the loop, which just makes it much more convenient for your users if they're already trusting of the tools that the agent can call. So I'm going to run this again. And so this time when I ask Ralph what active campaigns we have, we should get a response with that one campaign that we just ran. So Ralph queries the database and then sees that we do indeed have one campaign. And then I'll just ask it, look through our CRM data and identify another campaign that we can run. Okay, so it's summarizing once again the different customer segments that we have in our CRM data, and that's coming from a specific table, which we'll take a look at in a bit, but essentially we have a way to just quickly run a Python script that labels customers based on different metrics, as we'll see. Ralph is suggesting that we could run a loyalty campaign to the champions, or we can do a referral campaign for the big spenders and frequent buyers. This time I've just told it to go ahead and run our loyalty campaign for the champion segment. And once it's done sending all those emails out, post a detailed summary to the marketing Slack channel so that our team can get an instant update of this campaign and the results. And remember that we set this to YOLO mode. So this time you can see it creates a new campaign. It doesn't ask me. It just starts going into its tool calling. And hopefully it will be able to send all those emails out and give us a nice summary in Slack. So now we're getting all of those email tool calls printed out. And now you can see it's checking the list of channels that we have in our Slack, and it's identified the channel it wants to post to, and now it's posting a message. So it's probably done 20 plus tool calls at this point, and it looks like it's finally done. So I want to show you in Langsmith, since we did set up tracing for our project, we can look at the full trace of this run. It took about 71 seconds for the whole thing to run, and we started with our input message, which was run the loyalty campaign for the champion segment. And once you're done sending all of the emails, post a detailed summary to the marketing Slack channel. So it went and created that campaign. It got that feedback that the campaign was created. Then it ran some query, and then it gets that feedback again, and then calls another query tool. And then it's going to call, and this is the really cool part. So if you haven't seen the previous videos that we made on how to create MCP servers, I highly recommend going and checking that out since we do go into more detail about building your MCP server. And we talk about why it's so important to build your MCP servers with async tools. Here we then call the send campaign email tool. And because our tools are async, these are all called in parallel, however many 10 or 12 emails this was. They all get sent out in parallel, and so the whole thing only takes about 2 seconds for that node. And then we go back to the assistant. The assistant is going to call the Slack list channels, identify the channel that it wants to post to, and then post that message. Hopping over into Slack, I have this marketing campaigns channel that I created and connected the agent to. And here is the beautiful summary that we got back from our agent about the loyalty campaign that I just ran. It has some details, including how many customers were emailed and the specific target segment. Now in this example where we set it into YOLO mode, we only sent out 10 emails, but you can imagine extending this to a much larger data set. This data set I had to shrink in order for it to not just take forever for you guys to download and set up in Supabase. But, imagine you had hundreds, if not thousands of emails that you had to send. By setting it up asynchronously like that, you could send those all out in parallel, saving you so much time. So I hope it's super clear the utility in this CRM agent and the incredible amount of value that it can bring to any business. We were able to analyze CRM data, create new email campaigns, send out in parallel batch emails for a given campaign, and then even set a YOLO mode where it's fully autonomous and we don't really have to mess around by approving tools or giving feedback. Although if you wanted that fine-grained control, that's also built into the system if you're running something that needs a little more hand-holding. Now let's get into the code and see how this works. To get started, we're going to grab the Git URL from the repo, which will be linked in the description. And as always, there is a very detailed README if you want to follow along. Now, once you've cloned the repo, then we're going to start setting up our environment. The first thing you're going to want to do is open up the terminal, and I always recommend using UV. So check out the link in the description. If you haven't used UV, it'll walk you through how to install it both on Windows and Mac. So we're going to run UV sync, and that's going to go ahead and take care of creating the virtual environment for us in our current working directory, and also installing all of the required dependencies in the Pi project toml. Once that's set up, the next thing we need to do is set up our environment variables. I have 2 sets here that are required, and the rest is optional. If you did want to have that Slack integration, it takes a little more setup. It's not too bad. I've included the link here, but you're going to need to get a team ID and also generate a Slack bot token for where you want to create that bot and give it access to. And then, as always, I recommend Langsmith for observability and tracing, so you can create a Langsmith API key and set it here. But the required ones are OpenAI, since we use ChatGPT 4.1 for this, and also Supabase, which I will walk you through. But first, go ahead and set up your OpenAI API key. Next, head over to Supabase and create an account if you haven't already. Supabase is a backend as a service and allows us to create a Postgres database in the cloud that is really convenient to use. They've got a great dashboard and GUI that we can leverage, so we don't have to do a bunch of coding to get the database set up, and it will also be completely free. They have a very generous free tier, which is what we'll be using. So once you create an account, you're going to want to create a new project, and we'll just call that CRM Agent. And then you want to use the tool that they have here for generating a strong password. You're going to copy that password and then hit create new project. Go ahead and save that password in the env file, and then head back over to Supabase, where we're going to click on the connect button at the very top, and you're going to scroll down to the transaction pooler and copy this whole URL here. And then you're going to save that to the environment file as well. And then very importantly, you have to copy the password from the previous step and replace the placeholder in this Supabase URI with your real password, and go ahead and save that. For the 2 optional configurations for Slack and Langsmith, again, you don't have to do this to follow along, but feel free to visit this mcp.so URL here to set up your Slack configuration, and then also add your Langsmith API key here for traceability. Once you're done with the environment variables, we're going to rename this file to just .env. So we're going to get rid of the .example at the end, and that's going to set our official environment file. The last thing we need to do is set up Supabase. In this DB folder, you'll find the data inside of the data directory. These are the different tables that we'll be setting up in Supabase. The online retail, that's the original data. From that, we extracted these different tables just to organize it a little more. And all of the data processing and setup steps, including generating this new RFM table, which I'll explain in a bit, is in this Python file. So if you are interested in how the data was cleaned, this data, by the way, is a real data set. I'll link the original data set on Kaggle. It is for an online e-commerce store from the UK. So this is real data. The only thing that's not real is the customer data, which of course I had to synthesize. But everything else as far as the data setup is all in here if you want to check that out. I made this super easy to set up Supabase this time by creating this migration file. So you don't have to do any of the SQL yourself. It's all in here already. What you're going to want to do is just copy the entire contents of this SQL file and then head back over to Supabase. Now, Supabase makes it really convenient for running SQL queries. If you go to the left sidebar, you can click on this SQL editor. You might see this screen, or you might already have an input box for SQL. But if you don't, you're going to click on this new SQL snippet. Here is where we can input our SQL. So we're just going to paste that into there. You don't want to have any text highlighted. Just make sure that you click your cursor to that very last empty line, because if you do highlight a specific row and hit run, it will only run that row. So you can click run, and then you should see a success message if all the tables were created. Next, you can go back to the sidebar and click on the table editor. And this is where we can see all of the new tables that were generated in the public schema. And we can click on any of these. So if we click on customer, you'll see that it is empty. But if you hover over the customers table, you'll see these three dots. You can click on edit table. And then this is where you can see all of the settings for this table in a GUI. So these are the different columns and their types, as well as some additional settings for each column. We're going to populate this by importing the CSV files in the repo. So you can go ahead and click on import data from CSV and either select this box to browse or just drag and drop. You can navigate in your file system to your repo folder and then go to the DB and then data directory. And we're just going to take the customer's CSV first and then drag and drop that. And you'll see this automatically read a preview of the data set. We can click on import data, and that's going to populate the entire data with the correct types that was set in the SQL already. The next, we're going to do items, and then transactions, and then lastly RFM. The transactions table has around 10,000 rows, just 8,700, so a little bit less than 10,000. So it might take a few seconds to load. So the last one to do is RFM. Cool, and now all of the data is uploaded. So let's take a look at this data. It's pretty straightforward for customers. For the transactions table, we're going to have an invoice number, a stock number, the invoice date, and the amount, as well as price that was purchased for that particular stock item, and then the total price, as well as the customer that this invoice belongs to. And then we separated out the items into its own table based on stock code. So we have a description of each item as well as the price per unit. And then finally, this is a table that didn't come with the data set, but that we created. So this is similar to something that it would be part of the business logic that you would have in your system, where for each customer, we're just pulling all of their transaction history and then giving them this RFM score. So if you're not too familiar with RFM analysis, RFM stands for recency, frequency, and monetary. Recency being how recently did they make a purchase. So this is just going to be equal to the number of days between today and the last time they made a purchase. Frequency is how many times total have they made a purchase with us. And then monetary is the total dollar amount of purchases that they've made. Now, these are on totally different scales, so we need a way to normalize that. And so that's where these other scores come in, capital RFM, standing for the same thing, where we're just going to take quantiles, or basically look at the full range of each one of these metrics across all customers and then bin them into 20% increments. So 5 is the highest score that you can have, 1 is the lowest score. So a 5 would correspond to the top 20% of customers. For frequency, that would mean the top 20% of customers that made the most frequent purchases. And similarly for monetary, it'd be the top 20% of customers that have spent the most with us, whereas 1 would be the bottom 20%. So that's RFM, and then we can combine them into just a whole number by appending them to each other, and you get this RFM score, which here we have for this customer 355, and that just gives us a way to look at just one metric that kind of combines all of these scores together. And then based on this total score, we can then segment the customer, and in that, again, you can look at how this code was actually ran by looking at that Python file. But essentially, it's a way for us to attach a persona or a description for that segment of buyer. So in this case, because we have a 5 in frequency for this customer, we've labeled them as a frequent buyer. A champion is someone who has a top 20% score or a 5 in every category. And similarly, there are other segments here. And then lastly, we have our marketing tables, which will be empty since these are the ones that the agent will populate. We have our marketing campaigns table. We have ID, name, type, which a campaign has to fall within just 3 types, and we define that in our client or in our app. And then the description of the campaign, as well as when it was created. And then finally, the campaign emails, which is going to track every email that's sent with a unique ID, tying it to a specific campaign and specific customer that it was sent to. And then you've got the subject body, as well as some other metrics. Cool. So that's the data. Now that we have the database set up, we can pop back over to the code. And the first thing we want to do is open up this chatlocal.py in the front end folder and run this just to make sure that everything was indeed set up properly. So we can highlight all of this and hit Shift Enter to run in interactive mode. So actually, one thing we forgot to do, since we are using Ralph as a module here, which is our local agent, our local library, we need to actually install the current project as a package. So that's why we're getting this import error here. So to do that, we had to run one more command after running uv sync. Actually, it's uv pip install -e dot. So this command will install our current package in editable mode, and that will allow us to import Ralph or our agent as a module here. So if you hit enter there, that gets installed. You should see CRM agent was added, and now we should be able to rerun this. So I'll close that, highlight everything, and then hit Shift Enter again, and now we should see this run. Okay, cool. So now we know that this is up and running, and we can just ask, do we have any active campaigns, just to test that it has access to the database. So it does call a query, and it looks like it did get an answer back from the database. So now we know everything is connected properly. So we can just type exit and that will escape the chat loop. Let's talk about how we built this agent. You have the DB folder, which we just covered. That's going to be where all of the data is, and also the SQL migration file for creating the database tables. Then you have your front end folder. That's where we have our chat file, and that's going to contain our while loop for interacting with the agent. Not the focus of this video, but you can check out the Intro to Langgraph video to see more about how we set up streaming for this agent and parse tool calls and all that. And then you have the source folder. So this project is set up kind of like a full stack mono repo. The source folder is going to contain the backend code, which is going to have our agent code. So all of that is in the Ralph directory. And you've got a few files in here. You have your typical Langgraph graph file. Then you have your prompts file, which is going to have the system prompt. But I want to start with the MCP folder. So this my MCP folder, we're setting it up like a module that we're going to be able to import. So we're going to have that init.py file. And then very importantly, we have our MCP config.json. This is where we're defining all of the MCP servers that we want to use with our agent. There's only 3 here, and we kind of covered that in the diagram. So you have the Postgres server. This is coming directly from the Model Context Protocol. This is an official server developed by them. I've also talked about in the MCP intro video. Check that out if you haven't already, where we deep dive into creating your own MCP servers and connecting any arbitrary MCP server to Langgraph. But in our JSON definition here, we never want to put in secrets. And so the way you encode them is by doing this $ curly bracket and then the name of the environment variable, and we inject that later on, as we'll see in a bit. And then you have the Slack server, which again is coming from the official Model Context Protocol. And here we're injecting 2 secrets for the Slack bot token and the Slack team ID. And then finally, we have our own custom marketing server, which is going to be in this local directory here in the servers folder. So we're going to get into that, but first I'll show you the config.py file. So this file is something that I always have in my custom MCP folder, where I'm going to use it to resolve any local relative paths to absolute paths. So sometimes you have issues, especially on Mac, I've noticed, where if you put a relative path, that doesn't always work. And so this config file will just look for the PyProject toml for this project to save that as the root directory, and then from there it can recreate all of the absolute paths to the rest of these files. So that's what we're doing here. We have a couple of functions to resolve the paths, and then finally you have one function that's going to inject all of the environment variables. So we're using the .env library and the load.env method, which is just going to hierarchically look it within our project to find that .env file and then load all of the environment variables from it. And it's really simple. It's just going to look for strings that start with this $ curly bracket, and then it's going to extract the environment variable name, and then it's going to get that from the OS environment variables, which we loaded with the load.env method above. And then it's going to go ahead and set those environment variables in the config. And then so down here, we're just running those 3 methods. And then finally, we get back our MCP config with all of the environment variables fully loaded. We also do have a catch up here. So if the environment variable that we find in the MCP config is not found in the .env file, so if it's none or it's equal to an empty string, then what we do is we say we're going to skip that server because that environment variable is not set. And so what we do at the end here is that we're just going to iterate through each server. And if we flagged a server that didn't have an environment variable set but requires one, we're going to go ahead and delete that MCP server so that it doesn't error out in the client. But then your agent wouldn't have access to that. And so we're adding those print statements just to warn us that some MCP servers were skipped. So that's the config file. Hopping into the servers, we have one custom server that we set up, the marketing server. And again, we're not going to cover everything here. We're just going to kind of talk through it. But if you are interested in how you would build your own MCP server from scratch and connecting it to your agents in Langgraph, then definitely check out the MCP intro video that's in the description. So for our MCP server, really the only functions that it needs to have is to be able to talk to our database and specifically create new marketing campaigns and also log any emails that were sent. And so the first thing we're going to do is use SQL Alchemy, which allows us to create a database engine and then put in the Supabase URI from our environment variables as a connection string. That allows us to then start a local session where we can go ahead and call SQL statements against our database. So for our MCP server, we're naming it marketing. And then the first tool that we're going to register is the create campaign tool. As we saw in the traces, you always want to be setting up your functions here as async methods. That's going to allow your agent to call many tool calls in parallel, which is super important when you're doing any kind of CRUD operations so that you're not really bottlenecking your agent in performing this work. The other thing I want to mention is, so for this example, for creating campaigns, we're asking the agent to pass a name for the campaign, a type for the campaign, which you can see from the type hint here, we're specifying it has to be one of these three. It has to be either a loyalty, a referral, or a re-engagement campaign, and then a brief description of the campaign. So we're constraining the model to specifically when we want it to create a campaign, all it needs to specify is these three variables. And I want to take a minute to talk about why it's so important to think about your tool design. We could have easily given the agent just the ability to execute arbitrary SQL against our database, right? So it could have generated all of this SQL itself. It's not too complicated. But the problem with that is that you have, depending on your model capability, depending on the temperature settings that you've set, and in general, the fact that models are stochastic and they're not always predictable, for this type of work, you really want reproducibility. And so the best way to implement tools sometimes is to just constrain the model as much as possible. And I think that's generally a really good design principle. So whenever you're designing tools, you want to constrain the model as much as possible because it reduces the chance that a model can make mistakes and therefore increases your reliability for your application. Again, here we're constraining it where it's not actually writing any SQL. We've already written a valid SQL statement that we know works, and we are letting it inject. Another example would be if you're running queries against a database, and if you go and check out the official Postgres server from the Model Context Protocol, you'll see that it is a read-only MCP. So actually, I can show you that here, popping over to the official Postgres server from the Model Context Protocol GitHub. When the model calls this tool and passes in a SQL statement via the query parameter, it gets sandwiched between this begin transaction read-only statement, which is going to constrain the SQL in here to be read-only. So if the statement had a delete or update method in there, then this would fail. It would catch this error and then it would roll back that transaction. So that's an example of how the official Postgres server is really constraining the model there. Now going back over to the marketing server, we actually only have two methods here. So the first one was to create the campaign. And once we've executed this insert into the marketing campaigns table, what we get back in the result is just the ID of the new campaign. So that's what we're returning here as a string. The second method that we have is to send a campaign email. And again, we're constraining the model here. If we wanted to, we could constrain this even more by not giving it the opportunity to put in a campaign ID, since it has to generate this hash which, is prone to errors since it's a pretty long string as a UUID. What we could do instead is in our state, for example, have an active campaign. And so when it creates a new campaign in this method up here, we can set a state variable equal to the campaign ID of the active campaign. And then that way it wouldn't have to pass it. It would only have to give us these other parameters for the customer ID, the subject, and the body. And honestly, even the customer ID, we could have separated out as well, where it's already set based on whoever is logged in or using our app, for example. And so we would only ask it to give us really a subject and body. So that constrains this tool even more. But for this example, we're just passing these in as parameters, and I haven't seen any issues with the model getting this wrong. But if you were using a less capable model than GPT 4.1, which we're using here, actually GPT 4.1 mini, then you might run into some problems. So in this tool, I have a to-do here, since we're not sending an actual email, because I didn't want to go through the trouble of actually sending out real emails to my own email and then going into my inbox and showing you that. But essentially here you would put in the logic for actually sending the email. So whether that's a service that you use, an email service, or you were just using Gmail or something, then you could connect that MCP as well. And you can call MCPs within other MCPs. Which maybe I'll show a video about that in the future. But essentially here you would call your send email method, and then this is where we're creating the email record in the database. And again, we're using this predefined SQL and then just injecting the variables that are passed in by the model. So that's campaign ID, customer ID, subject, and body. And then finally, we're returning a message that the email was successfully sent to that customer. And that's really it for the custom MCP that we have. We have two methods for creating campaigns and sending campaign emails. Now let's take a look at the graph. In our graph file, we're going to have your typical Langgraph design pattern, which is defining the state first and then having a method to build the actual graph. And if this isn't super familiar to you, please go watch the intro to Langgraph video where we do a much deeper dive. Our state is just going to have three parameters: messages, which is always going to be our default parameter for tracking our conversation history. And then we have two new parameters. Protected tools is going to be a list of strings, and these strings are just going to be the names of tools that we want to put behind the human in the loop protection. So if you include the name here, then whenever that tool is called, there will be an interrupt in the graph execution, and you will have to get feedback from the human to either approve the tool, deny the tool, or provide feedback to the model, as we'll see in a bit. We also have the flag YOLO mode, which is just a Boolean, and by default it's set to false. So if it's false, that means every tool call to a protected tool will cause an interrupt and require human input. Whereas if it's set to true, it's just going to go ahead and bypass that human in the loop, where all of these tools, regardless of whether they're protected or not, will just be automatically called by the model. So that's our state. In our previous MCP video, we showed how you could instantiate this client in the front end app and then pass it into the build graph method. In this case, we're just including it in this build graph method so that whenever we build the graph, the tools will automatically get bound to our LLM. And so that's what we're doing here. We're again using the LangChain MCP adapters client, which this client is super convenient because it allows you to just define that MCP config JSON that we're loading from the MyMCP folder over here. And you can have an unlimited number of MCP servers in that dictionary and then just pass all of that in, and this one client is going to handle all of the connections to the various MCP servers. So super convenient way to do that in Langgraph. I actually really love this because it's just literally one line. And then to get the tools, you can just call .get tools on that client, which is async, so we have to await it. And then once we have those tools, we can bind them to our LLM. And again, here we're using GPT 4.1 Mini, which I have found to be a really good tool calling model. Once we've defined our LLM, then we have our assistant node. Here is where we're going to pass in the system message plus whatever state messages we have or the conversation history that we're tracking in the state. This Ralph system prompt is being imported from prompts.py. So let's take a look at this really quick. It's a pretty long prompt, mostly because we're including all of the database schema, which is that entire SQL file essentially. So it's pretty long. And then we're also describing what tools within those MCP servers it can use. In the system prompt, I'm giving Ralph its persona as a customer service agent and marketing expert. And I'm also telling it, in addition to the tools that it has available, what its overall goal is. So that is to deeply understand customer behavior, preferences, and needs, and then use that information to create highly targeted marketing campaigns. So as Ralph works through your queries, whether it's to analyze the CRM data or figure out what campaigns can we run next, it's always going to have that clear goal in mind. And so it will lean towards doing analysis, for example, on customers and their purchase history before sending out emails, because we've instructed it to create highly targeted or personalized campaigns. That's the system prompt, and you can really do a lot more with this. This is really just a basic prompt because most of this, again, is describing the database schema and tools. We've only have like a very small set of instructions that we've given it as far as how we want it to accomplish those things and how we want it to behave. So hopping back over to the graph file, this is arguably the most important part of Ralph, which is the human tool review node, and that's what's enabling human in the loop. So I'm going to talk about it briefly here, but I will be doing a much deeper dive in the next video on human in the loop, because I think it's one of the most important and critical design features of any AI agent that you're deploying to production. In Langgraph, human in the loop is achieved by two core features. One is the interrupt method, and the second one is this command object. So let's talk about the interrupt method. This method can be called anywhere within a node. As the Python script gets executed and the graph gets to this point in the code, once it's going to hit this interrupt method, which is going to stop the graph execution. Our graph state is then going to get updated to reflect the fact that we've hit an interrupt. And other things will be recorded in the state, like which node the graph was interrupted at and what the next node should be, as well as some additional information which we can pass in as arguments to this interrupt function. And this can be of any type. Typically, you're going to pass in a dictionary like this. It could be a string, but passing in a dictionary /JSON just makes it a lot easier to parse the data. So here we're passing in a message, which we want to then display on the front end, for example, and then the tool call. And again, since it's a dictionary, if we did have a UI on the front end, or like we're doing with our chat file, we can then pull out these specific parts of the dictionary by just calling these keys. And then, for example, we could display this message along with some nice UI element for the tool call. So once the graph actually gets interrupted at this particular node, on the front end, we're going to collect two pieces of information from the user. One is an action, and one is the data associated with that action, if any. So the allowable actions are continue, update, or feedback. Continue just means we want to approve the tool without modifying or changing anything. So just go ahead and execute the tool. Update would be if we wanted to actually change an argument for the tool call. And then feedback would be if we want to give some natural language input back to the LLM so that it can adjust how it's calling the tool, or maybe just completely switching directions, for example. So the first thing we do is we check what was the action that the user wanted to take. If it is continue, then we're going to return this command object. And this command object takes 4 different inputs. So you can pass in different combinations of these. In this case, if you just pass in go to, we can just pass in the name of the next node that we want to go to. And here we're just saying go to the tools node and go ahead and execute that tool. The update and feedback options are a little more interesting. So if we want to update the tool call, the way we actually do it is by updating the AI message that called the tool. And the way you do that in Langgraph is by recreating a new AI message, and we give it the same ID as the previous message that we want to update. And what this actually does is just completely replace the previous message at that ID with this new message that we're creating here. And so we're keeping the content the same as the last message. Then what we're doing is we're updating the tool call itself, keeping the same tool call ID and name, but just now passing in the data that we're collecting up here from the interrupt. And we'll see how we're collecting that from the front end in a bit. And then again, we can return this command object, and instead of just having a go-to defined here, which in this case is just going to be the same thing, it's going to be going to the tools node because we actually want the agent to now go ahead and execute this tool, but with these new arguments that we've defined. And so we're also going to pass in an update to the messages key and then pass in this new message that we just created here. And that's going to completely replace the previous message at this ID. So hopefully that makes sense. And then finally, you have feedback. Now in Langgraph, whenever an agent calls a tool, the next message in the message history has to be a tool message, which is just the response from the tool. So we're kind of taking advantage of that requirement in Langgraph by creating a tool message and then adding our feedback as the content for that message, and then updating the messages key to add that tool message. What we're putting into this tool message would be our feedback that we're collecting here from the interrupt, and that's going to come from the front end again. Once we add that tool message as a response to the messages key, it goes back to the assistant node now, and the assistant would review the input that we gave it or the feedback that we gave it in the form of the tool message. And an example I played with this agent was when it created some of the initial personal emails, I felt like they were a little too stiff, and so I asked it to add some emojis. And so then it went ahead and called the send campaign emails again, but this time added some emojis to the message. So that's just an example of how you can provide it feedback, but you can provide it other feedback like, changing tone or including instead of 2 past purchases, maybe include 4 or 5 for the email. Finally, we have our assistant router, which is just going to be the edge function that we're using to route after the assistant node. So this is what the graph looks like. And so these conditional edges or dashed edges coming out of the assistant node are the options that the assistant node has to route from. So that's all defined by our assistant router. So if there are no tool calls, for example, then we just go to end. So that's going to be this edge here. If there are tool calls and one of them is within our protected tool calls, then we're going to send it over to the human tool review node. And so that's this edge here. Otherwise, if it is a tool call, but it's not in a protected route, then we just simply route it directly to tools. And that's this final edge out here. And then from tools, we always route back to the assistant node so that the assistant node can go ahead and get that feedback of the tool output and then decide what it wants to do next. So that's the agent graph. And I'll show you also in the front end, going to the chatlocal.py, where I mentioned you can get that input from the user. So in our main while loop, which is also our chat loop, what we're doing is after every response from the graph, we're going to get the latest thread state, and we're going to check that state for any interrupts. As long as there is an interrupt, we are going to collect two pieces of information from the user. So remember that the interrupt function allows us to collect an action and then also the data associated with that action. So here we're just going to collect the action. We're asking the user to either specify continue, update, or feedback. And then if they haven't entered something that's within those options, then we're just asking them to do it again. If the user has specified that they just want to continue, then we don't need to pass in any data back into the graph. We're just simply going to route it to the tools node. But if it's either update or feedback, then we are passing in data. And so we're going to have to collect that from the user through this input. Once we have those two pieces of information, then we can re-invoke the graph and stream the responses by passing in the command object again. This time we're passing in this resume parameter, which is going to tell the graph that we now want to go and resume from where we interrupted last. Here is the data that you need. We have the action and the data, but essentially we're passing in those two pieces of data. So going back to the graph, that's again being passed in from this interrupt function to this human review dictionary. And then that's where we're going to be pulling out those two parameters here. So we'll go into a lot more detail for human in the loop in a next video if you are interested in that. But that is everything it took to build this agent. Finally, I want to again end on discussing how this design of this agent can really be expanded to any kind of data, where as long as we have our agent and we've connected it to these really useful MCP servers, even adding our custom MCP server here and connecting it to a backend database, it really unlocks a lot of automation and the ability to just do tons of work with just simple natural language and instruction. This is really how you can start to unlock your own productivity, but also whether it's for your company or a company that you work for. And this is where I'm seeing a lot of value being driven, is in these types of workflow automations where, you know, it would take you forever to draft all of those emails, but it takes an LLM seconds. And so really those low-hanging fruits are the first ones that we want to prioritize in automations. So hopefully you can really see how this can be extended to all types of data and businesses, and hopefully you found it useful. I am really curious to hear from all of you. Post down in the comments if you would like to share what you're working on, how you are leveraging AI, because I would love to understand what your applications are as I think about making these videos. Everything that we covered here, including all of the code, is free for you to use. It will be included in the description. Thank you guys so much for watching, and I hope to see you in the next one. Bye.